Martin, what were you about to say?
Oh, just, I can keep my eyes open, but, they want to close sometimes. It's not for sleep. It's just sort of like, oh my goodness, there's so much coming in.
Absolutely. And we are
It's
now live
hypnotic.
on YouTube as well. So just to let everyone know, we are now live on. And something about going live on YouTube has made my mouse go a little crazy. I think my bandwidth has dropped. So, Sherelle, would you mind welcoming people and start chatter because my computer is not happy.
Absolutely. Hello, everyone, and welcome to Live from LPSC 52. Woo! Thank you for joining us, and thank you for your continued support. It's going to be an awesome discussion tonight, so get ready to put those questions in the chat box. All right, so, ladies and gentlemen, as you see, as you're coming into the room and you see all those words popping up at the bottom of the screen, if that's annoying you, just select the live transcript and hide them. You do not need them if you wish to not have them, but we want them available for everyone that would like to see them. So that's an option for you. I would like to introduce myself to you. Who is this lady? Who is this lady talking to me? My name is Sherelle Webb. I am an education specialist at the Lunar and Planetary Institute, and I'm so happy that you're joining us tonight. I am not going to be your main speaker. You're probably happy about that. It's going to be Christine Schupler. But anyways, we're going to have an awesome time. So as you all know that our live is going to be recorded. Well, it's playing live at on YouTube as well. And we like for all of your comments and questions to go in the Q&A box or the chat box. All right. So take it away, Christine.
Thank you so much, Sherelle. We're glad to have all of you with us here tonight, and we're just getting started with our Thursday night for Live from LPSC. This event is for the general public. We're glad to have you with us. It's free, and everyone is welcome to join us. We've got some great speakers. Sherelle, would you mind moving us along to the second slide now? The Lunar and Planetary Science Conference is held annually in March by LPI and NASA Johnson Space Center. We have a variety of specialists in science topics who present the latest research in planetary science. And to find out more about the conference itself or to look at the abstracts, those abstracts are publicly available. Go to LPSC's website. Just Google LPSC 2021 and that'll bring you there. Sherelle, let's go ahead to the next slide and start to introduce all of our participants. So the way tonight is going to go, we're going to start off with our introductions. Then Ed is going to give a short presentation about Arecibo Observatory. Yay! And then we're going to have a panel discussion and Q&A. All of our attendees are invited to enter questions into the Q&A. You're also welcome to enter your own thoughts in the chat to share with each other. This is meant to be a discussion. And we're delighted to have so many great people with us. Let's go ahead on to the next slide and let's go around and introduce ourselves. Before we get to tonight's panelists, I'm Christine Schupler from LPI, as Sherelle mentioned. Also, Yolanda, would you mind please introducing yourself?
Hello there, everyone. Thank you all so much for being with us today. I'm Yolanda Ballard. I am part of the support team for LPI. I'm the program coordinator for the education. And I'm going to be working in the backgrounds. I'm not going to talk very much, but I am going to be monitoring the chats via YouTube and here and helping out in that capacity today. Thank you all for joining.
Thank you so much, Yolanda. Ed, please introduce yourself.
Saludos, everyone. I'm Edgar Rivera Valentine. I'm a planetary scientist at the Lunar and Planetary Institute. I used to work at the Arecibo Observatory, and the type of research I do spans from planetary defense to astrobiology.
Thank you, Ed. Caitlin, let's go ahead and have you chat for a second or two.
Great. Hi, everybody. I'm Caitlin Ahrens. I'm a NASA postdoctoral fellow at Goddard Space Flight Center here at Greenbelt, Maryland. And I mainly work on ice at the lunar poles, and I'm also on the Lunar Reconnaissance Orbiter Diviner science team.
Thank you so much. Dr. Ana Maria Beria.
Hi, everyone. My name is Ana Maria Berea. I'm an associate professor of data sciences at George Mason University. I'm also affiliated with NASA Frontier Development Lab with Blue Marble Space Institute of Science. I mostly work at the intersection of data sciences and space sciences with a focus on astrobiology. Thank you.
Thank you. And Martin Hajovsky.
Hi, I'm Martin Hajovsky. I work for myself, but I'm a microblogger for the LPSC. This is my 4th year running doing it, and I love it. It's just been fantastic.
Awesome. We're glad to have you with us again. And Genesis Vargas, please introduce yourself.
Hi, everyone. I'm Genesis Vargas. I am an alumni from the Star Academy at the Arecibo Observatory, and I'm currently a high school senior. And this year I submitted my abstract and overall research on cognitive functions of astronauts in space. So that was a great opportunity for me. Thank you for being here.
Thank you. So folks, we're glad to have you with us. As Sherelle mentioned at the beginning, you're welcome to enter your thoughts in the chat. You're welcome to enter questions in the Q&A. Those of you who are joining by YouTube, you're welcome to enter your comments and questions on YouTube, and Yolanda will let us know about them. And as Sherelle mentioned earlier, if the captions at the bottom are distracting, you can turn them off if you have joined us by Zoom. Just click on where it says more and tell it to hide subtitles. And that way those will go away. Sherelle and Ed. Sherelle, you can either move to the next slide, or Ed, would you like to share your own slides, your preference?
Okay, so y'all should be able to see my slides.
We can see your whole screen right now. There we go. Looks perfect.
There you go. Okay. All right, so I'm going to be doing something a little bit different than what has been done in the past, in that instead of talking about a session that happened today at LPSC, I'm going to be talking about a session that happens tomorrow, celebrating the legacy of the Arecibo Observatory, specifically in the planetary sciences. So quick summary of what AO is. For those of you who don't know, the Arecibo Observatory is in Arecibo, Puerto Rico, which is actually where I was born. It is a huge 305-meter radio telescope. And one of the really neat things about the Arecibo Observatory is that, unlike other telescopes where you kind of have to sit there and wait for that random piece of light from the universe to hit your telescope and then either hit your eye or come over to an equipment, the Arecibo Observatory had the ability to emit light. So it was a huge flashlight, basically. And with it, we could literally elucidate near-Earth asteroids, the moon, and pretty much any planetary body from Mercury out to Saturn. And it's that power that let us be able to explore the solar system, take images of the surfaces of these places, find ices where we didn't expect it, and be able to characterize asteroids for what's called planetary defense, which I'll explain here in a bit. So I'm going to be highlighting some of the talks that are going to be in tomorrow's session, and then ending with, again, celebrating the beautiful legacy of the observatory. So selfishly, I'm going to start off with my own talk. I mentioned that with Arecibo, you were able to see ice. And in fact, one of the first results that we got back when we studied Mercury was, oh wait, there's ice at the poles of Mercury, the planet closest to the sun. That kind of doesn't make sense. So in the early 90s, we took these beautiful radar images and found that the poles were just super, super shiny, which tells you that, hey, there might be ice there. And that motivated an entire NASA mission called Messenger that went over to study Mercury and got awesome data over the poles and showed us that, yep, there's ice there. And so I end up giving a talk at this session going over that data and new data that I've taken and then putting that all together with the messenger mission and with these new machine learning algorithms and other stuff to be able to study the data that we're seeing and be able to tell you, how deeply buried the ice is and exactly how far it's distributed and whatnot. Now with radar and the fact that Arecibo has been operating for so long, we're able to keep taking really neat images of the surfaces of planetary bodies. And that's really special for Venus, because Venus, we know at least at some point or another, it had volcanoes all over the place, erupting all over the place. But we don't know if it's still active today. But because we were able to take images from example here, 1988 to 2017, we can study these different volcanoes on the surface of Venus and say, hey, has there been changes? Are we seeing changes? Because if we see something, a new feature on this, that could be evidence of volcanism today. And so there's a talk by Bruce Campbell from the Smithsonian Museum going over that legacy of data from Arecibo and understanding if Venus is active presently. But one of the most impactful things that Arecibo really brought to society was planetary defense. That's the knowledge of near-Earth asteroids, making sure that whenever we find one of these new objects, we characterize them really well and make sure we know their orbit from now to several years, hundreds of years into the future. And you need to know that to make sure that this asteroid, is it going to be dangerous or is it okay? With Arecibo, we were able to tell you how far away it was, down to a meter. And remember, these objects are typically flying, millions of kilometers away. We could also tell you their speed down to centimeters per second. And these objects are flying at dozens of kilometers per second. If you put that together, you can get a really precise orbit. And that informs the NASA, it informs the entire world. Is this going to be dangerous or not? But we moved even further than that. We did more service than that. We weren't just Nostradamus, just sitting around telling you this might happen. No. We worked to mitigate these impacts. With the type of data that we got from these asteroids, we would get these really beautiful images like you see here of 2015 TB145, which is an asteroid that's about 600 meters in size. And yeah, it looks like a skull, and that kind of surprised me and us when we were studying this, because we studied it the night before Halloween, so that was a little weird. It turns out, remember I said flashlight, right? So when we flashed our light onto this asteroid, there was boulders on its surface and they cast shadows behind it. And that's why it looks like a skull. But look at these beautiful images, right? I can tell you those were boulders. I can keep taking images and put them together and get these really neat movies out of this. And it's not just going, ooh, pretty. It's, ooh, this thing is probably spherical in shape, right? And putting all of these images together, we could get a full 3D shape model of these objects. And you want to know that shape, because if something spherical, like you see here, examples of shapes, or if it's something like a bone heading towards Earth, the type of way that you're going to mitigate that impact, that's going to be very different depending on the shape. And so with the Arecibo Observatory, we were able to survey all of these objects that were coming close by. We were able to get you all this amazing data to understand the variation in sizes and shapes of these objects. And that's important to defend the world, but also important if you're going to go visit these places. And in fact, it was Arecibo data that facilitated the Osiris-Rex mission, right? Osiris-Rex went to visit Bennu, and it was the beautiful radar data sets that we had that prepared the mission to know what it was going to visit. And so Michael Nolan is giving the talk about this variation in sizes and shapes and all of the beautiful data that we've gotten with the Arecibo Observatory. But you know what? Arecibo didn't end there. It wasn't just there to give us all the beautiful planetary science that it got us, and it wasn't just there to defend the world from devastation. Arecibo had a beautiful human impact. I am in science because of Arecibo. Like I told you, I was born in the city of Arecibo. It inspired me to come into science. And I was lucky enough to work at the observatory and to lead a program that educated and reached out to the community. And I got to see the community inspired by the observatory, and they wanted to go study astronomy and they wanted to go study planetary science. So Arecibo's impact, its legacy, it's defending the world, and it's a true human impact. And with that, I'll pass it back to Christine.
Thank you, Ed. Thank you so much. That's great. So, folks, we can start with questions for Dr. Edgar Rivera Valentine. And from there, we'll proceed on to discuss other things that that we saw and heard today. And I would particularly like to hear a little bit from Genesis about the program that she was involved in at Arecibo. So let's go ahead and see who has a question so far. And
Why?
Please
Anna Maria
go ahead.
does.
Okay,
Sorry.
great.
Oh, I was wondering if you could speak about the cultural impact that Arecibo has had on Puerto Rico as a whole.
Yeah, Arecibo, because it has been around for so long, since the 1960s, it's really woven itself into our culture. When you fly into San Juan, you're gonna see a mural of the observatory. When you're driving around in the city of Arecibo, you're gonna see a mural of the observatory. When you're watching the news, you're going to see pictures of the observatory. For us in PR, you know, it's the pinnacle of science. When you think of really cool science, you're thinking of the observatory. It has been definitely a source of inspiration for the entire island. One of the really neat things that came about in December after the tragic events was seeing a bunch of people on Twitter talking about how they're in biology, they're pursuing a medical degree, they're in chemistry, they're in all these different fields of science because when they were kids, they visited the observatory.
And I'd also like to add to what Ed said that almost every student in Puerto Rico has probably taken a field trip to the observatory. I know I went there when I was like in 4th grade. I went there again when I think I was like in middle school. And at the time, even though like not many kids are really thinking about careers or college or anything, you know, it's still an inspiration and trying to get kids involved in what's going on in Puerto Rico in science. Like right now for me, I for one, like throughout high school always was involved in many areas. Like I really liked music, literature, and science was also an area, like, but it was never something I specifically dove into until the Star Academy. And it really just educative programs and like outreach programs, they really do provide a sense of direction for the youth here. And not only in astronomy, but just like getting into other fields like biology, chemistry. Like so many students from the UPR are actually involved in research with the observatory and many other professors. We had guest speakers from the university and from all over the world. So it's not just something that impacts here at home, it's also something that inspires the youth here to try to reach it towards like a higher goal in mind and understand that science is for everyone.
Awesome. Awesome. Anna Maria, I know that you had a question. Ed, I will unpin you. Thank you so much. And I have a polling question for all of our participants, for all of those of you who are attending us tonight. Wanted to know a little bit more about you. You heard a little bit about us and who we are. So let us know a little bit more about you. You have 10 seconds. You can pick multiple choices, or you can pick just one, your choice. So are you curious about the planetary science? Don't know much, but you'd like to know more? Do you enjoy learning about the solar system? Are you studying planetary science? Are you a student? Are you a solar system ambassador? Are you an amateur astronomer? Are you a planetary scientist? Are you actually attending the LPSC conference? Or are you being forced to attend this against your will? So we'll give you 5 more seconds to finish answering. And 4, and 3, and 2, and 1. And it looks like people really enjoy learning about the solar system. We're so glad to have you with us. And a few of you are actually attending the science conference. This is our outreach program for it. So we're glad to have you with us, and feel free to share your thoughts in the chat. And if you need to or would like to share your thoughts verbally, raise your hand. Anna Maria, you had a question earlier. Would you mind sharing it?
Yeah, it's more of a comment. Besides the legacy for science that Arecibo has, I actually wrote an article about the legacy for data science from Arecibo, because it's one of those instruments that has been collecting data for 57 years so far. So that's a lot of data. From what I understand so far, currently on site, there are maybe 1 petabyte of data that rests either on servers or on even tapes, because in the old days, right, they didn't have computers. They had those old tapes where they collected all the data. And some of it is also backed up by other universities, right, like the University of Arizona or the University of Central Florida, who is also part of running the observatory. So I'm really interested in, and actually I have been doing a little bit of work into understanding the legacy for the data sciences from the space sciences and from such observatories, because in data sciences also we have the evolution of all these algorithms. You are mentioning machine learning, right? But in time we have better and better algorithms, and we have better and better computational capacity to analyze all these data sets, right, that are huge and have not been fully explored yet. So I think it's a wonderful wealth of data that lies with the observatory over there. So yeah, thank you.
Awesome. So I have a question for everyone that's here with us. What did you hear today that you found really interesting that you'd like to share? What science did you hear today that was exciting? And I saw a big grin on Caitlin's face, so I'm going to pick on you, Dr. Ahrens.
Oh, yes. There were quite a few lunar science special sessions earlier today, part 1 and then a part 2, luckily with a minor break in between, because it started off with all of these mission concepts, and the concepts are now becoming a reality. And now there's this huge excitement of how we're preparing ourselves for the Artemis program. And all these landers and rovers on not just on a national scale, but also an international collaboratory of lunar science. And it's so exciting to hear people from like the Chinese Space Agency. We have JAXA, we have the Indian Space Agency as well coming into play. We have the Russian Space Agency, Roscosmos, coming in. So it's going to be such a wonderful international collaboration of all of these wonderful concepts. And I'm really excited for the rover called Viper, which is the Volatile Investigating Polar Exploration Rover. And that's going to be really exciting, because we understand that there's water ice at the poles of the moon, but also there's other types of ice on the moon as well that we definitely want to explore way more, and all the technology that we can learn from a rover before we send the Artemis astronauts is going to be really exciting.
Fabulous. Thank you, Caitlin. That's great to hear. Oh, one of my usual questions about the moon when it comes to exploring the moon or other planets or asteroids, would you go to the moon if you could? Caitlin says no. Anna Maria, I saw you nodding your head. Do you want to? Yes, you would. Okay. Okay. Ed, how about you? If you could go to the moon or Mars or an asteroid, would you?
If I could personally, or if we could send someone up there?
If you could personally go.
Depends how old I am. Though Mars would be super neat. I mean, I would go to Mars and then lay there and sleep for a while.
Yolanda, you have a question for us.
Yes, I do have a YouTube question. And of course, we are a little bit behind, but the question is, what future space missions are any of you most excited for?
Anna Maria.
I would have to say Dragonfly towards Titan, which is going to, I mean, it's going to be a while, right? It's in many years. It was just announced, I think, last year maybe, but it's one of those deep space missions where we are looking for life on another moon, on another planet, basically. So yeah.
Awesome. Ed, how about you?
Europa Clipper. Right, we're sending a mission to Europa, an ocean world nearby. It might have plumes. It's going to take radar with it. I mean, if we're going to be finding life nearby, my bets are honestly on Europa. And so I'm hoping the Clipper flies by one of the plumes and a big Kraken comes out and lives high. That's all I'm hoping for.
That would be great. Caitlin, how about you?
I'm gonna have to agree with Anna Maria here with Dragonfly. Just there's so much that we need to know about just Titan's origins. Was it considered an actual moon? Is it a captured planet? Why does it have a thick atmosphere? Why does it have its own climate? It has a beautiful thick atmosphere. It has rain clouds. It rains methane on Titan, and it fills up the beautiful lakes and oceans across Titan, and then it evaporates and creates the clouds. And it's very similar to our water cycle here on Earth, but also it's very, very cold as well. And so understanding the climate, why is Titan the only one? Where was its origins? Really, really pulling for Dragonfly here. And also it's a drone. So how cool is that?
Very, very cool. Martin, do you have a favorite mission?
Well, in an odd kind of way, because first off, I love Dragonfly and I love Europa Clipper. And after today, after the sessions I sat through today, I want any Venus mission I can get my hands on. Would be just wonderful. But personally, I have to say, in an odd way, I'm most excited about the Eclipse missions that are going to the moon, robotic missions to the moon. But the reason why I have a very personal interest is that the son of very good friends of mine who works for Firefly, and Firefly is sending a lander in the Eclipse programs to Mare Crisium, and I'm very excited about that for him. So
Awesome. Yes, of course. Genesis, do you have a favorite mission, a favorite planetary mission?
Well, I know this is on pretty much everyone's mind currently, but it's the Artemis mission. Although I would love to witness like missions to especially the gaseous planets. Like yeah, that would be super interesting because of atmospheric sciences, but also the Artemis mission will be probably my generation's mission. And it also focuses on sustainability, which is something I'm really interested about. And I think it would definitely add to technology and space exploration overall. So I'm really excited for that one.
Thank you so much. I have a question for you, but also for all of our attendees. So where would you go? How would you prefer to learn about the solar system if you could? You know, what's your preferred method of learning about the solar system, of exploring? Would you prefer to use a great telescope like Arecibo, preferably in an awesome location like Puerto Rico? You want to listen to talks and hear from scientists, maybe even meet a scientist or two, watching great shows and videos, reading books, articles, and blogs. Martin's an author. So would you like to participate in a robotic planetary mission? Would you want to become an astronaut yourself and go to wherever it is? And do you have other ideas that aren't here that you want to add into the chat? That would be awesome to see. I'm going to give everyone about 10 more seconds to answer. 5, 4, 3, 2, 1. And it looks like a lot of you really enjoy hearing talks and hearing from scientists, and that is awesome. That's a great way to, but we also, some of you want to become an astronaut and go one of these places yourself in person. A lot of you would like to use a great telescope yourself, or you know, all of these things. So if you have additional ideas, please enter them. And it looks like, Sherelle, you've got something to say, please.
You know what? I want to take the Q&A question first before I
Please.
ask my question.
Please.
Okay, so this question comes from Mr. Richard. Leaving out the historical and cultural importance, do you feel that decommissioning the Arecibo Observatory was the right technical decision, or were its capabilities bypassed by later generations of radio observatories? Or was it just a matter of economics?
Okay, so I'm going to take that. So there's two things that come up when we're talking about the observatory and people think about new technology, new stuff, right? First, okay, there's going to be three. First of all, just because it's been there since the 1960s don't mean it was useless. The Arecibo Observatory is one of two active radars, was one of two active radars in the entire world studying asteroids that might impact the Earth. Without the Arecibo Observatory, we are now seeing less asteroids because of Arecibo's size. It was able to see twice as many space rocks as the other active radar, which is the Goldstone Solar System radar in California. So now we are missing out on literally seeing potential impactors. And then the other thing that comes up is how about the new telescope that China built, FAST, the 500-meter aperture spherical telescope. So there's a couple of things there. First of all, that does not have a radar. It is a radio telescope. So that's the version at the beginning of my talk where I said you have to wait for light to come and get collected. It does not shed light onto near-Earth asteroids. It does not do any of that. The other thing is, FAST isn't actually 500 meters. So FAST actually deformed into a much smaller 300-meter dish when it goes to observe. Arecibo was 305 meters. 300, 305, I'm just saying, Arecibo was better. So when we're talking about bypassing and surpassing technology, no, we haven't. Can we improve? Could we have improved Arecibo if there was more funding to give it better technology and make it even better? Yes. But right now, we are flying, not seeing half of the asteroids that we could be. So that's my input.
Woo! That's all I have to say about that. Definitely very passionate about that. And I know everyone felt that heat. All right. So thank you, Ed. Okay. So my question is that, there is a lot of opportunity for citizen science. So what opportunity that you want, people to know about or get involved in? And to spell out the question, I wrote it down so I wouldn't mess up the verbiage, but here it goes. We have a lot of opportunities for citizen science. What's one opportunity you wish everyone knew about that could get involved with your current research or with other research?
I'd like to take that one first. At least for me, as a student, one doesn't really think that there's an opportunity for you to do research or somehow try to be on the level of a full-on scientist, especially, you don't really have a degree yet or anything like that. But I would like to emphasize that just reaching out to local universities and local programs, like at least here, like the Star Academy, and just programs in the UPR, that really helped me out, because my school specifically doesn't really have that many clubs. It doesn't really have an astronomy club or even a science club. And so it was difficult finding programs like that. And the best thing is always to look at the public sector, because there's always going to be people who may be in more diverse fields and who might even be able to contact others, and you may make more connections with even people your age. Like for me, I was able to meet people my age who were probably going to go to the same university as me, or who were already involved in research, and that really gave me direction and a boost in really what I wanted to do. So I just encourage people, especially young people in high school and in college, to just get involved in local programs and research, because it's also something that's experimental enough for you to dive into. There's always room for more information, and anyone can really try to contribute to the science community like that.
Thank you.
Fantastic. Thank you. Go ahead,
Anna
Christine.
Maria, you had something you wanted to add?
Yeah, so answering this question about citizen science, not exactly in the usual term that we understand citizen science, but in general, when we are talking about data science, so I bring up data science because that's my field, many people are finding data sets online, and they are coming up with innovative ways or innovative methods to analyze these data sets. And again, especially in this field, in space sciences, in lunar and planetary sciences, there is a wealth of data that even non-specialists, right, or scientists that are not exactly in this field or in these fields, they can actually tackle the data with a new eye and come in with new ways to approach these data sets and to analyze them. And sometimes we can find some very interesting and surprising answers. As Ed was mentioning at some point about asteroid shape modeling, right? And how we can use imaging, or how we can use again, some of the machine learning or deep learning methods that we have right now to create these images, right? These virtual images of to recreate these images of the asteroids. Data scientists can contribute to that as well, because in data sciences specifically, we also have open source algorithms, we have open source communities, and the communities again can be brought together to bring new analysis and the new eye into the field.
Awesome, awesome. We have a YouTube question, and the question is, are there any plans to study Apophis when it comes close in 2029? Since it will be close, shouldn't it be easy to land some spacecraft on it?
So there are definitely a bunch of plans to study Apophis. This is a marvelous opportunity for us to turn all telescopic eyes, everything we have on Earth, staring right at this, including yourself. By that time, you can go outside with binoculars and just look up and you will see this. So we are definitely planning. There has been discussions of thinking about sending stuff up there and getting closer data, maybe with a CubeSat or something. But that I know of, it hasn't been decided to go and see it with a spacecraft. It's all telescopes on Earth.
Awesome, awesome. And just in case any of our listeners aren't aware of what Apophis is, Ed, would you mind telling them a little bit about it?
So Apophis is a near-Earth asteroid. When it was first discovered, the data we had suggested that it might impact the Earth. So in 2029, it comes really, 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 really close. Like I said, you'll be able to see it. Luckily, with the Artemis data and other radar data that we got, we found out it's just coming really close. It's not going to impact. But it is also a potentially hazardous asteroid. So sometime in the far, far future, maybe, but for now, we're fine. We're cool, we're calm, we're collected.
Thank you.
Awesome, awesome. I'd like to ask all of our panelists to think a little bit about some of the science that was presented today or earlier this week. Were there stories that you would like to point out that were just really awesome? Science that you heard that was amazing, that you're looking forward to learning more about? Martin,
Sure, I've got some.
go right ahead.
Yeah. Well, today I was in all afternoon. I was in Venus sessions, and there was at one point I heard 3 talks in a row. The first one was there is no way Venus has ever been habitable at any point. Another one, the next one was, well, maybe it could be, and the last one was absolutely, it surely was. And to have these 3 talks go bang, bang, bang like that was fantastic to just sit there and understand, the diversity of potential answers right now, and also the need for further mission, because again, more data helps with this kind of thing, and everything is always more data, but in this case, that would really help constrain that answer. So that was wonderful. that was a wonderful experience today to sit there and listen to that one-on-one, and then the discussion afterwards to hear of all the panelists just talk about the science, talk about their, do their comparative work, was great. It was extraordinary.
That's amazing. That's amazing. And did you get the impression? Sometimes scientists disagree, and that's actually frequently, right? Scientists disagree as part of interpreting and understanding our data and our results. Martin, were any of the participants sometimes when we disagree, we tend to feel a little unhappy. Were they all pretty happy?
Absolutely. It was that, it's all, everyone's doing the same work, it's a communal activity, and everyone builds on everyone else's work. So, it was absolutely, collegial.
Awesome. That's wonderful. Thank you. Does anyone else have a story from this week or from today specifically that they'd like to highlight?
I couldn't really look at many live sessions because I just started school like in person. So I've been mostly just looking at the iPosters, especially from the astrobiology section and the space exploration section. It's super interesting how I saw one, I think like 2 days ago, where they were trying to see how plant fertilization could work on Mars, and it was super interesting because obviously when you're thinking of astronauts going on to Mars, and my research focused really on the cognitive functions of astronauts and how nutrition also affects that. So one question that I still had after my research was how we were necessarily going to grow these nutrients and once we get to these environments. And they had actually found that fertilization was the most important aspect of the whole plant process in on Mars, and that's what they had to focus on when bringing supplies to Mars, and a lot of it would have to be just fertilizer and all that stuff, and then also how that could impact sustainability and how they had to alter materials on our way to Mars. So I thought that was really interesting and a great application of earth sciences in space exploration.
Great example. Thank you. And let's see, Caitlin, you had your hand up.
Yes, one thing that I find interesting too is in between sessions there tends to be after discussions with groups, and it's very interesting to hear not only people who would go like, oh, what if we modeled that, but you also have a laboratory experimental aspect of stuff too, that we want to better understand the material science of planets. How you have volcanoes and volcanic flows on these surfaces, or glaciers on Pluto, or Titan dunes. We want to understand all these materials, and now it's getting into ideas of, can we recreate planets in the laboratory? And it sounds very much like mad science though, but it is a possibility in some aspects, but we're very behind on lab work. There needs to still be a lot more lab work that needs to be done for definitely analog studies. You can only do so much on Earth. You can only do so much in the field as well, and that can only go so far. But trying to do like low temperature studies or high temperature, high pressure studies for Venus, it's so fascinating to see the collaboration of laboratory people and go like, oh, can we recreate that in the lab? And then what kind of instruments do we need? And how can we be very careful not to blow up the lab at the same time?
Great point. Very great point. Let's see. Ed, there were a couple of questions that you answered in writing, but for those who are on YouTube who couldn't hear your answers, would you like to talk about either of them?
Sure. So there was a question that came in about, so are there other facilities such as ALMA and FAST that can pick up some of the planetary science projects that the SEWA was working on? So ALMA and FAST, again, those are radio telescopes, not radars, so they won't be able to, but the Goldstone Solar System radar in California, it will be able to do some of the planetary science projects, some of those asteroids, and some of the planet part of the radar that we were doing. But because the Goldstone Solar System radar is a bit smaller and its radar itself is less powerful, it won't be able to do everything and all of the projects that were on board for the Odyssey Observatory. So there are some projects that just cannot be done elsewhere currently today on Earth. And then there was another question that came in. So what's the latest status of the double asteroid redirection test mission? So for those of you who don't know, part of Planetary Defense is developing technologies in case that there is an impact, we can go and push it away. The DART mission, double asteroid redirection test, was actually going to go and test one of these technologies and see if it's viable to defend the world. It was slated to launch this summer, but a decision in February 17th, this past February 17th, was to push the launch date into what's called the second window, which is between November of this year through February of next year. So that's when the new launch is going to be.
Thank you, Ed. So, folks, what other questions do you have for us? What other questions do you have for our scientists and for all of our panelists? Do you have other thoughts that have occurred to you that you'd like to share about stories that you found fascinating? Or do you want to share a little bit more about your own research? Ed.
Yeah, I'm trying to avoid not to talk too much, but no one has mentioned Mars 2020. And so at LPSC, this awesome mission that just recently landed on Mars, we got to see some really awesome preliminary results. Okay, so I am super duper excited for this mission, to get all this data down, to see it trek across. This mission, besides taking a lot of the instrumentation that Curiosity had, it has a bunch of new stuff like a radar. So obviously it's awesome. But then it's also paving the way for human exploration of Mars and picking up samples. So it's going to be going around and going, oh, this rock looks interesting. Let's cache it away and let humans at one point or another, or a robot, go over, pick it up and bring it back to Earth so we can then do the experiments that Caitlin was talking about right here on Earth with these awesome Mars rocks. And then the other work I do, I like to study and understand if liquids are stable on Mars. Specifically what's called a brine, so really salty liquids. And the data that this mission is going to get us back with its climate data, so telling us the temperature, the humidity, and all that, paired with the radar part of it, is really going to push forward that science of understanding, are there liquids on Mars? And if so, how habitable are they? And can, life actually be there?
Very cool. Good point. Great point. I'm going to share another poll for everyone. I'm going to let our panelists vote on this one too, but all of our attendees and panelists, there's 2 questions to this poll. Have you attended live from LPSC, this public event that we're talking about right now that we're doing? No, yes in previous years, yes earlier this week, you're not sure because you don't really understand what it was, or you don't remember if it was this or something else. But the other question is, would you like to attend this next year live from LPSC? So anyway, I'm going to give everyone another 10 seconds. Actually, let's make it 5 seconds to finish answering these 2 questions. You only get to pick one answer per question. You don't get to pick multiple answers. And 4, 3, 2, and 1. And thank you so much. Looks like a number of you have attended earlier this week. We're glad you're back with us again. And some of you actually attended in previous years as well. A couple of you have never been to this before. We're glad to have you with us tonight. And so would you like to attend it next year? A lot of you will. That's great. Thank you so much. Speaking of next year, I asked a tough question last night, and I'm going to repeat it with you all. What are you looking forward to hearing more about in a year? What results, what new information, what missions, what questions have we asked that you're hoping we might have some answers to in a year? What are you looking forward to hear about more next year during LPSC?
March 2020 first year results. Easily. That's going to be a fantastic thing to find out, and just to get that first year, just the initial results. Because I think that when you saw where they plan to go just within the first year, it's going to be a remarkable series of traverses theoretically, And and it's that mission puts you on another planet in a way that very few things are. And I always knew that having a microphone would be a thing. It would be an interesting thing. It's of course it brings some interesting data, but just as as a cultural thing, it also puts you on the planet to sit there and listen. There was it's something got released yesterday, which is the sound of the rover just clumping and clumping and clumping across Mars, and it's like, that sounds like the ricketiest thing I've ever heard. And I was like, but no, of course not. It's rolling over rocks. It's rolling in through pits. It's getting banged around and as it moves. And I was like, oh my goodness gracious, I hope that thing's robust. but it was fantastic to hear, because suddenly, in a sense, to have that additional sense data is fantastic. So a year from now, it'll be interesting to see exactly what the first year of results will be, especially over the traverse that they have planned. Very ambitious, although one of the people on board was talking about the long-term traverse and says, yeah, for all you curiosity people telling us it's too ambitious, we're planning for success. I was like, okay, good for you. So
Awesome. Wonderful. Wonderful. Anyone have other ideas?
I was in some of the posters that I was looking at, and also a few talks. They were talking a lot about climate history and just the origins of most of the planets, especially the Saturn and Mercury. And Saturn, Mercury, and Venus were some of my favorite like planets that I saw that they were exploring climate in, and I really want to see more results for that in the next year.
Thank you. Thank you. Yeah. More about the climate of other planets, especially some of these awesome planets, Venus and Mercury. Oh, Anna Maria, you had something you wanted to say or add.
Yeah, so I would be really interested to find out more this year about the work that is being done on the informational limits to life. Sarah Walker, for instance, she is one of the scientists who is working on this by looking at network theory of chemicals, right? And looking at chemical bonds through this different lens of using network science. So it would be very interesting. It's a field I'm also working in, basically. If we are looking at life from the informational perspective, what advances can we bring to the field of astrobiology? And obviously, since Venus has been mentioned here a few times, I would really like to see where the debate about the phosphine is going. So, yeah.
Since you brought it up, Anna Maria, would you mind describing the debate about phosphine for anyone who is unfamiliar with it?
Oh, well, as it was mentioned, I think probably by Edgar Martin here before, it's basically the debate is whether this compound that has been observed and analyzed in the atmosphere of Venus, does it come from biotic sources or abiotic sources, right? Is it a chemistry that we don't know about, or is it actually, that some form of life that we don't know about, right? So that's the gist of the debate. Also, there is around it, there is also the debate about the actual data analysis and the actual whether the actual amounts of the phosphine that have been detected, whether they are the accurate amounts and so on. So there is also this debate, and obviously, like I think Martin mentioned this before, until we have a mission that goes towards Venus to collect more data, the debate is going to be mostly around the data analysis and the science that we know so far about it. So,
thank you. Oh, so Caitlin, did you have something that you're looking forward to over the next year?
All the science. I think something that I'm gonna sound like a broken record here with laboratory experiments again, but so many laboratory experiments have been shut down, unfortunately, all through last year, and they're still slowly getting back up and ready. And so it'd be really nice to have a boom of laboratory experiments that just did not get there due to the pandemic. And we're going to hopefully see a boom of experiments that are finally getting done. And if anything, just provide more questions for us to explore.
I completely agree with Caitlin. One of the projects I'm working on is using lab experiments from viruses interactions, and we just don't have enough data we have all the computational resources that we can for running simulations and for doing all that, but we just don't have enough actual real lab data to validate our scenarios. So I completely agree with you. Yeah.
Thank you. Thank you. There were a couple of stories that I've heard this week. I wanted to see what you all think about. So, of course, there's been quite a bit of discussion about the Artemis mission and plans to go to the moon. But related to the moon, we heard about ANXA, how they opened up some of the samples from Apollo from a while back. So are any of you excited about hearing more about the results from the testing of these Apollo samples from the moon?
Absolutely. So what's interesting, though, is again, back to laboratory work here. The fact that they haven't been open for so long is incredibly exciting, but we also were very, very cautious of how we were going to open it and make sure that they were still as pristine as possible. And we're learning. This is certainly still a learning curve of we have not done this before at all. And so whenever it was, popped out of the tube here kind of deal, there was, just like a slight release of chemicals there and a slight loss, if anything, very, very, hopefully very, very immeasurable there. But it's still a learning curve for us of, okay, what can we improve for next time we bring back samples? And then how do we learn about the samples brought back from Apollo? Even astronaut Harrison Schmitt did a talk regarding those samples as well. And he was very excited too. And all of us lunar people were asking him questions like, what do you think about us opening a sample that like you essentially got to help with? And he was so excited that it can still be used and it's still valuable data. It wasn't just collecting dust on a shelf kind of deal. It's still valuable, and it's still, like I said, a learning curve for whenever we collect more samples with Artemis.
Thank you. Sherelle, I think you had a question here from the Q&A.
Sure, absolutely. Okay, so this is anyone stab. So how is Bennu and the other asteroid different from the other near Earth asteroid? I'm not even going to butcher it. So how do we choose to collect samples from them, but not the others from the NEAs?
Good question. So Ryugu and Bennu are interesting in that. So Ryugu is about 1 kilometer in size. Bennu's about half the size. But if I were to send you pictures of both of them, you would be staring at them going, wait, which one's which? Their shapes look very, very similar to each other. So from a how do asteroids form perspective, it's interesting to see two objects that are very different in size be so similar looking. It's also interesting to see when you get there, the type of processes you're seeing on the surface, right? So are there more craters on one versus the other? Do you see more like fine grains rolling off of one versus the other because you're different gravity regimes? And that again goes back to how did these objects even form and evolve? Now in choosing to go, so I'm not a meteoricist, but I'm sure I know there was reasons in terms of like why these specific types of asteroids, B-types asteroids were chosen. But in terms of the other side of why do we send missions to where we send them to, including the surface of Mars, it's you have to make sure that you have a high success chance. Bennu at one point had the best astrometry. That means we knew ridiculously super precisely where it was going to be 1 picosecond from now. And we knew exactly its velocity 1 picosecond from now. So if you're going to send a mission somewhere, you want to make sure that you are picking an asteroid who you know precisely where it's going to be, and you have all of this data, like the shape models and whatnot, to prepare. So especially for a sample return mission that actually has to go and figure out how to land and pick things up and bring it back. And for Bennu, one of the other reasons we chose it is the data that we were getting back from ground-based telescopes. They were telling us, oh yeah, there should be enough smooth places for you to go and collect samples from. But then we got there, and Bennu, if you've seen pictures of Bennu, it don't look that smooth. There are boulders everywhere. So that was interesting finding. So we now have to figure out why is that and what's happening. So actually, ever so slightly going back to a question that was asked beforehand, one of the best things about planetary science, and one of the best things I always look forward to about planetary science, is hearing that we were wrong, because that's where the best new science happens. So when this came about and it was like, wait, this is what we expected, I was like, yes, this is new science. This is the cool thing. So yeah.
Thank you. And I believe we have one last question. Yolanda, you have a question from YouTube?
Yes. What space missions are down the pipeline for Venus? Are there any?
So would anyone like to take the pick on this? Martin?
Well, currently there are several proposed, right? Because Veritas, Da Vinci, Envision from the ESA are all, but I'm not sure there's anything that's set yet. Although if you look, there were several posters. I think I counted 7 different posters that looked at 7 different possible balloon missions. That's an exciting idea, you know, for balloon missions in the clouds of Venus. But in terms of something that's definitely approved, I don't think so. I don't know.
Yeah.
But I don't think so.
And I think Parker, the solar probe, just passed by Venus, or is going to pass by Venus, and try to collect some data, although it's not designed for that kind of mission. Yeah.
Thank you. And you know what, folks? We are out of time. I have one final poll for everyone that we're going to go ahead and ask. And that is, I'd like very much to hear your thoughts about tonight. Thank you so much for joining us. So we've got just a couple questions here about how tonight's program affected your awareness of planetary science and exploration, and how it's affected your interest in planetary science and exploration. Please join me and all of us in thanking our speakers and panelists. We're so glad to have you with us here tonight for this. Thank you so much for spending time with us and energizing, as Richard says. And thank you to all of you who joined us tonight and spent your time with us to hear more about this. We're delighted to have you as well. We really appreciate all of you. And Mark, I'm sorry we didn't have time to answer your questions, but if you email us at education@lpi.usra.edu, we will get back to you, okay? Email us your questions at education@lpi.usra.edu. Thank you